Good morning, students. I am Shahnaz Fatima from CSE Institute of Technology and Engineering, affiliated to Jawaharlal Nehru Technological University, Kakinada. Let us study today what is K nearest neighbor algorithm, and we will apply it on the IRIS dataset and see the performance of it. So let us see what is K nearest neighbor algorithm. It is a supervised learning algorithm. So by supervised, I mean it knows what are the labels associated with that samples. Let us see an example. We have the data set which consists of all the training samples. These are the training samples. So among these training samples, when I construct the data set here, suppose I have the two variables or two features. So each training sample has got some feature x1 and x2. Each training sample has got some feature on x1 and x2. So depending upon these features, it has got some label. So I can assign the label as triangle, I can say, or I can say the label as red, or I can give a numeric value, let us say 1 to this. So it can be a categorical value or it can be a numerical value. So out of this data set, we have got a plot, and from visualization, it is very simple for us to see that what are the different classes. But when I give a sample, here this green sample is the test sample. It has to be assigned to one of the classes, either red, or I can call it as a triangle, or it has to be assigned to the blue, or it can be called as a square. So how to assign this test sample to one of the classes, either red, triangle, or a blue square? That is the main objective of the K nearest neighbor algorithm. So K nearest neighbor algorithm can be used for classification or regression. Today we are discussing about the classification problem on the IRIS dataset. Okay, so let us see a clear example working of the K nearest neighbor using steps. So the first step is choosing the value of K. What is K? Here is the number of neighbors. It is the number of neighbors. Let me call n. So by seeing how many neighbors, we will be able to assign it to one of the class. So let us say this is the data set. Again, as I have said, these are the features, x1, x2 are the features, and this gray sample is the test sample. And we have got three different classes here: the lime green, green, and orange. So I have to assign my test sample to one of the three classes. Our IRIS dataset, which we are using today, also has three samples: Setosa, Virginica, and another set of flower set. So out of these three classes, our test sample has to be allocated to one of the three. So what is the procedure? See, first we will calculate distances from our test sample to each one of the sample. So this is our test sample. We are calculating Euclidean distance. It can be any other distance also, like Manhattan distance. So at present we are calculating the Euclidean distance. So for all the test samples, we have to find what is the distance. So this is one of the drawback of K nearest neighbor algorithm. It will grow, like the calculation value still grows with the number of samples. So for large data sets, it becomes slow. Okay, so how do we calculate? For our test sample to the first lime green one. So we have found it as distance is equal to 2.1 metric. Second, again I am calculating distance from our test sample to another this lime green one. So it is now 2.4. So like this, all test samples we will arrange. So 1, 2, 3, 4, 5, 6, 7, 8. So likewise, we will continue with all the test samples 1, 2, 3, 4, 5, 6, 7, 8. So for all the test samples, we have to calculate the distance. So this is the overhead in K nearest neighbor algorithm, that it grows with the number of test samples. So now after finding all the distances, we will arrange them in increasing order of distances. Already it is done here. So we can use any of the sorting algorithm like bubble sort, quick sort. So again, it depends upon the limitations. We have to select the choice also. So now we are not considering any sorting technique here. Already it is assumed to be sorted, and we have put them in increasing order. Now comes the value of K. So K, let us suppose we have chosen K value of 4. So 4 nearest neighbors. We have to choose the 4 nearest neighbors. So if the distance from our test sample to the first line grade one is 2.1, it is the first nearest neighbor. Similarly, again, the next nearest neighbor is the another neon green one, which is 2.4. It is the second nearest neighbor. Second nearest neighbor. So third one is this green one. It is the third nearest neighbor, and this is the fourth nearest neighbor. So we have successfully found out the fourth nearest neighbor depending upon our chosen value of k. So this is our next task. Now what we have to do is we have to take the votes. So we have taken depending upon the value of k is 4. We have chosen the 4 samples and we have found the distances to that. Now we have to give the vote. Vote for what? Vote for which class? So if I assign this gray sample to neon green, how many votes are there for neon green? Neon green votes are now 2. Similarly, this green color vote is 1 and orange color vote is 1. So neon green is winning here with 2 votes. So I have to assign my test sample to neon green class. So this is the procedure for the k-nearest neighbor classification algorithm. Only mathematical overhead is finding the distance. Again, the distance can be Euclidean distance or Manhattan distance or any other distance. So this is the simple formula for Euclidean distance which we have been using from childhood. So this is the root of square of xi minus yi square. Okay. So from the point, suppose xi belongs to our test sample and yi belongs to our sample which we are using from another class. So advantages, as we have seen, it is very simple to understand. Just find the distances to each sample, arrange them in increasing order and choose the number of samples, how many you want to take for assigning the votes. It is easy to implement, just Euclidean distance, and no training phase is required. And for small data sets, it is easy. Likewise, I have said here, for large data sets, it is slow. And it is sensitive to noisy data. If there is some noise and the value is changing, the feature values are changing, then the Euclidean distance will change and it will affect the decision on the voting. Okay. Now let us come to our data set, what we are using here, the IRIS data set. So IRIS data set is very simple. It has been first used by Ronald Fisher in 1960s. I don't know the exact date. Okay. So here it consists of 3 classes. Setosa, versicolor and virginica with 4 features: sepal length, sepal width, petal length and petal width. So it is very simple. It has only 4 features and it has only 3 classes. All data is not much different. So you can assume the flower, what will be the normal size of the petal, size of the sepals and all. So they are not very far from each other, and the classes are Setosa is linearly separable. Setosa values are linearly separable from versicolor and virginica, which are having slight overlap. So versicolor and virginica, they are having slight overlap, while Setosa is linearly separable from these 2 classes. So it can be used for performance comparison for linearly and non-linearly separable data, and it is a very basic data set used for performance of any ML algorithm. So applications, for many applications it can be used for pattern recognition, image classification, etc. So we will use now we will use on the IRIS data set. I have just written that it depends upon the value of k, distance metric, Manhattan or Euclidean distance, and the quality of data sets, that is depending upon the noise. If the feature values are changing, the Euclidean distance also will change and it will affect the performance. So let us see now, using a Python program, evaluation of k-nearest neighbor performance accuracy on the IRIS dataset. So these are the libraries which we are importing, which will be necessary for us to run the program. So here we are importing the IRIS dataset. So the first cell is the importing. We are importing all the libraries which will require. So we are importing the IRIS dataset from sklearn. We are importing the train test split function again from the sklearn. And we are importing the k-nearest neighbor. We will use it for fitting the model and again predicting the test classes. And we are importing the accuracy score function from the sklearn. Now let us see. We are loading our data set into this IRIS variable, and we are extracting the data and target into x and y. And we have already imported the train test split function, and we are taking 30% of the samples, 30% of the samples for test and 70% sample to the train. And we can write here the random value as 42, otherwise it will take different values. Okay, let us take train test split as 0.3 Now we are using the k nearest neighbor algorithm. We have used the k nearest neighbor values as 6. We can change this. We will change and we will see what will be the effect on the different values of k nearest neighbors value, k value. Okay. So after selecting the nearest values of 6, we are model fitting the k nearest neighbor values with the given train and test. Already we have here chosen the train and test data and labels. So using this, we will fit the KNN model, and again this is for predicting the y value. So we have predicted y value and we have actual y value. Okay. So for the given x test, we have already y test. This is the actual y value and this is the predicted y value. Using the actual and predicted, we are going to test the accuracy. So here we are going to test the accuracy for all the test samples what we have taken. So we know the Setosa, Virginica and Vergicolor, they are 50 samples each in the IRIS dataset. So out of this, we have taken 50 of each class, means total 150 are there. Out of that, we have taken 30% as the test set. So 30% of 150 is about 45. So we have, out of this 45 values, we are taking the length of the test, which is nothing but 45. So we know the range, it will take from 0 values. So it will go from 0 to 44. So we have taken it as I plus 1. This is nothing but 1 to 45. So what we will do for each value of test. So we have taken test samples 45. So for each value of test sample, it will evaluate what is the predicted values, predicted y values, and already we have the test samples. So it will compare between predicted and tests, y predicted and y tests, and if they are equal, it is the correct prediction. So the correct will be incremented. If they are not equal, it is wrong. So based upon correct values and wrong values, we will find the accuracy. So let us run the program. So we have imported all the, we have all the imports. Okay, we are loading and we are assigning the to x and y. We have train test split. We are splitting into train and test of 32 and 70%. We are running the classifier. We are running the fit function and predict function. And we have found the predictions. So for different samples, we can see from sample 1, actual label is 0, predicted label is 0. Actually, we have now here in the classes 0, Setosa, Virginica and Vergicolor. These are the names. These are nothing but the categorical variables. But here it is written as 0. So we can give 0 for the Setosa, Vergicolor for 1 and Virginica for value of 2. Okay. So this is how it is done. So 0 is identified, 0 is predicted as 0. If the test sample is 0, predicted as 0, so it is correct. Similarly, for all the 45 test samples we have found, and depending upon all the results, we will get the accuracy of the model. So we can here change the value of k, which is nothing but the number of nearest neighbors. From 6, let me say it is 3. And we can run the model again, and we can see what is the prediction. So 95.56. So it depends upon how many correct predictions and wrong predictions. So here by our choice we are writing it 3 or 6, but in general it will be like a grid search where we can take value of k as 1 to 6 like that, and the program will find out for which value of k we are getting the best accuracy, and it will return the value of k. So here it is user dependent, we can give the value of k here. Now for a test sample, arbitrarily we can choose the value of sepal length, sepal width, petal length and petal width, and whenever we give this test sample to the predict function, we are getting the prediction. So here what we are doing, as I have said, for Setosa we are getting 0 value. That prediction we are giving, we are converting it to the names. So 0 is predicted to Setosa. It is given the value name as Setosa. So this is how we have seen that for on IRIS dataset, it is giving a higher accuracy of 95.56%. So in this way, this is for KNN. So in this way, we can apply the another ML algorithms on the same dataset, and we can find out which one is working best on this dataset, or which value of k is getting the good results. Okay. So thank you all. Today we have learned what is KNN, what is IRIS dataset, what is supervised learning, and how to evaluate the performance on the IRIS dataset using the KNN. Thank you.